Okay, good morning. So the next section in the book, it is called Direct Proof, the book that I uploaded for you on the Google Classroom. Of course, there is nothing that much I can say about direct proof, okay? Because whatever you usually use as a proof is a direct proof, okay? We have different other types of proofs, proof by contradiction, proof by induction, and these kinds of things we will discuss later. But direct proof is not something that I can talk a lot about it. Whatever you have, for example, you can say that for prove the following statement, okay? Prove the following statement. So we say that for all, in the book they are not using this symbol, but it is not complicated, so let us learn that. For all a and b belonging to the set of real numbers, a plus b to the power of 3 is equal to a cubed plus 3a squared, b plus 3ab squared, and then plus b cubed, yes? So this is a statement we want to prove, okay? So I just chose this example because this part of the book is not algebraically complicated. The goal is to teach you what are the meaning of these words and terminologies we're using. Okay, so what should I do here? So first of all, do you remember when you see this universal quantifier? It means that bringing an example is not enough. You have to have an argument to show that it works for all choices of A and B. If you want to write the proof formally, so you say that, okay, let A and B be real numbers. And don't hesitate to write words. We will discuss a little bit today about this. Let A and B be real numbers. Then, so what can I write? I can write the left-hand side is equal to A plus B to the power of 3. Okay? And then I want to manipulate this algebraically so that I can reach to the other side. Okay? It is up to you. The definition is important. First of all, what you need to consider is what is the meaning of this symbol. Okay, so you need to remind yourself about a definition that you have learned at some point. Okay, so and that is the definition of a number raised to a power. So what is the definition here? What is the meaning of a number raised to power 3?
The number multiplied
by itself 3 times. Yes? So this is what I'm trying to I told you, whenever you want to prove something, this refers to some definition in mathematics. If you don't know what is the meaning of this symbol, it is completely useless to think about to prove it because you don't know the meaning of the symbol. So you have a definition before, and that was how a power is defined, and then you want to use that. Okay, so you can write a plus b times a plus b times a plus b, okay? But you can also use the rules that you have already have, and that you can write it, for example, a plus b to power 2, yes, times a plus b. Why this is better than the previous case? Because first of all, this is the rule that you learned before. If I have a number to power 2 multiplied by itself one more time, it becomes the same number to power 3. This was one of the rules that you have learned before. So I am using my definition first, and then I am using a rule that I already know. Okay? Why this is better than starting from scratch? Because of course you can start with from scratch by writing a plus b times a plus b times a plus b, but you have to work harder after that. Yes? But here, if I use a rule that I have already proven, I can go do it faster. Why this is better? Because I already remember something about this. Okay, so if you don't remember that thing about this, of course you have to start from scratch. It means that it takes longer. So that's why I'm saying that it is not good to start everything from scratch. It is better to reduce the new problem to a simpler problem that we already solved. This is the idea that you should have in your head. So this is power 3. It is a harder problem than power 2, but I reduce this new problem to a problem that I already know how to solve. And then I continue that. This phrase that I'm using try to learn it over and over again because I want to use it over and over again, yes? So then I know that rule. It becomes a squared plus 2ab plus b squared. And then I multiply it by a plus b. And then I know the rule is to distribute this. So a squared times a becomes a cubed. A squared times b becomes a squared b. And then I go here and do the same thing. So this is simple. So let me just do the algebra very fast. And if you have questions, of course, let me know. And then we know that here a cubed is alone, but a squared b and 2a squared b can be combined, and I can write this as 3a squared b. These two can also be combined. I can write it as 3ab squared, and then finally I have b cubed, and then I have the right hand side. Yes, so this is a direct proof. I mean, you don't need even to explain. If I wanted to prove this is equal to this in Math 2C, I did the same thing without mentioning that I am using the direct proof. But that's just the proof, okay? But let me try to ask you something else, okay? So, you know what an odd number is, okay? But I want you to write a definition for an odd number for me. Because in this part of the course, we want to practice how to write properly, not how, because usually, let us not say anything more. I want you to define an odd number for me. First of all, I want you to understand that it needs a definition, yes? Because in English, when you say something is odd, it means it is a strange. But you are saying odd number, yes? What is the strange about odd numbers, okay? So it means that you have to define. You cannot teach the primary school kid 1, 2, 3, 4, and 5, and then in the exam ask the person, okay, write 3 odd numbers for me. Do you understand what I mean? This concept should be defined. So the notion of odd numbers should be defined. Otherwise, it doesn't make sense. The reason that you know it, because this has been defined for you long back, and then you understand that it's not natural. So it's not natural. So someone has to define it for you. Okay, I am waiting for you. Can you define an odd number for me? Very complete. Okay, because do you remember what was definition? We talked about that. What is the definition in mathematics?
Exact.
The precise description of a concept or an object or an idea. So a precise description. So I wanted to give me a precise description of what we are supposed to call an odd number. Yes?
Integers that aren't divisible by 2.
It's one way. Okay, divisibility comes next. When you learn arithmetic operations, you learn operations, which operations you learn first addition, then probably subtraction, and then multiplication. Let me just give you a constraint. Use only multiplication and addition, because you said that a number which is not divisible by 2, yes? By the way, how many of you agree with this definition of power 2, of an odd number? Do you agree? So he said that an odd number is a number which is not divisible by 2. Is it a good definition of an odd number, what we know about odd number, of course? Is it a good definition? So a square root of 2 is divisible by 2 or not?
Yes, we could. Wait. No.
So a square root of 2 is an odd number, according to your definition. I don't have any objection. If you want, you can define it whatever you use, but this is not what we have in our head as an odd number, yes? So this, I know what you mean, but this is not a precise description of what we're supposed to mean. I want you to train yourself to say something like that, yes?
An integer that's not divisible by 2.
An integer that's not divisible by 2, that's correct. Okay, but then we can say, I just want you to don't use divisibility. I want you to use multiplication and addition in your definition. By the way, don't think that this is a very strange idea, because in mathematics, when you define multiplication and addition, and then you can define the integers, before teaching the students about division, you can talk about odd numbers. Yes? But the way that you are defining, it means that we have to put a delay on defining an odd number so that the students learn about division and then they are able to define odd number. But this is not needed. Do you understand what I mean? At least you should understand. If your definition is correct, complete, but if I want to do that, I have to delay it until the students learn about division. Okay? But this idea you should have in the back of your mind. When you have a concept, when you learn something, you want to extract as much as possible from that thing that you have right now. Yes? Before even going further. Okay? Yes, Nathan?
Okay, I have a theory. Maybe if an odd number is when it's multiplied by itself, it becomes a new odd number. But when it's multiplied by maybe addition or like
It's not a good description because you yourself is confused, yes?
yeah, but like when it's added together, then it becomes
No, you are giving properties of odd numbers. You are saying that you have some idea about an odd number, and then you are telling me properties of odd numbers. But we want to define the odd number first. Yes? What's your name? Abraham, yes?
What if there's how about 2 times some numbers becomes an even number plus 1?
Okay. Can you formulate it precisely?
2 and
Your idea, this is what in mathematics is called a rough idea. But rough idea cannot be written down. You have to polish and edit it sometimes over and over and over again. Okay, now can you polish what you said?
2n plus 1.
So you say definition 2n plus 1. Okay, so how many of you agree with this one? How many? Raise your hands. It is meaningless. What you are thinking is correct, but do you agree grammatically it is wrong? We are humans, yes? When I say define an integer, when I say define a odd number, you say 2n plus 1. Do you think grammatically this is a correct response to me? No. Okay, can you polish it yourself?
N is an integer.
Better, but not finished? So you see that you are adding things. And that's what exactly I'm saying. N should be an integer. Either you write it in English, N is an integer, or if you want to write it in symbols, you write like that. N belongs to Z. Okay? So you understand that before doing that, you are putting it on me to decide what N is. But you are responsible for your own definition. Yes? So this definition does not work because some people can choose N to be 1/2 if you don't say so. Yes? And then I multiply 2 by 1/2, it becomes 1. 1 plus 1 is 2. Do you agree that 2 is even, is odd? No. So this is why. This part of the lesson, and then we will go fast after that, we do other things. But I want you to understand, you understand what you mean. But when you write a definition, you have to assume that I don't know anything, you define it completely. Yes? So now how many of you agree with that? Yes? It's not good. Yes? It is not a definition. Definition is a sentence. We are humans, we have to talk. Yes? So don't, because this, I wanted to take this off from your head. Mathematics is all just about symbols and numbers. Yes? This is not correct. So can you give me a better definition? Yes?
An odd number is an integer that cannot be expressed as a product of 2 and any other number, any other integer.
No, that I want to follow this because this idea is good, but it needs to be polished. What does it mean? When someone doesn't know what we are talking about, and then he comes to our classroom and see this on the board. Of course, if you know a little bit about mathematics, you can guess what we were talking about. But that is just a guess. It's not a definition. Yes?
Isn't an odd number a number that's any number, any integer?
No, this is correct. It is not a sentence. For example, I don't know how can I say that. Have you studied physics? For example, if I say what is force, you write, for example, F. Okay, so what is it? So you have to have a sentence at least to describe what you mean by a force. Okay? Yes.
An odd number is the sum of 1 plus an integer times 2.
No. So don't. This is completely correct. But you need to add. Okay, let me tell you. Okay. So this is the mathematical way. But still, you hesitate to write sentences. Yes. I would say I would say an integer. I am writing words. M is said to be an odd number if m is equal to 2 times n plus 1, comma, for some integer n. When I say definition, this is definition. I'm using what you said, but everyone read it, people understand what I'm talking about. If someone comes in, you see that is said to be an odd number. So first of all, that person realize what I am defining. Yes? So this is very important. What you want to define should be in your definition. The word that you want to define should be included into your definition. So now I am telling you that an integer, it is important, an integer m is said to be an odd number if m is equal to 2 times n plus 1. If I stop here, is that okay? No, because then people say that, okay, you talked about m, I know m is an integer, then what is n? You have to explain it. So then you would say that where for some integer n. Then everyone understands what is the meaning of this one, okay? So for example, let me ask you some question. This is definition, and I give you an example. Example. Then I can say this. This is the direct proof. Prove that 5 is odd. So what should I write now? So you start with proof. Okay. How do you write your proof? I want you to prove that 5 is odd. What does this mean? I need to show that 5 satisfies what I defined for you a moment late before. Yes, I just want to convince you that 5 is odd. What does it mean? I need to show you that 5 satisfies what I defined for an odd number. Is that right or not? Okay. But I want you to write it precisely. Just tell to me. So if you want, I can take my pen, you just dictate it and I will write it down. And then we fix it. I just want you to understand, because you see the algebra is very elementary. Okay? But I want you to learn how to write. Okay, what do I write here? Yes?
Let 5 be integer and that is the odd number. And then
No, we don't know yet it is odd. We want to show it is odd. Yes?
5 is an odd number because first it's an integer, and you can subtract it with 1 and then divide it by.
No, subtraction is not in my definition. Because you are saying that, okay, that's the same thing. It is equivalent to this, but don't invent new rules. You have to stick to exact definitions that you describe for me. Yes, this is important, but I want you to understand. I have given you a very simple definition of a very simple concept, and then I am asking you prove that 5 is odd. By the way, is it a very hard problem? No. Writing it down, you haven't used to it. I want you to learn that one. Yes?
2n plus 1, and then if you work out n and it's an integer, then it proves that 5 is an odd number.
It's not good. This is what you have done is a scratch work paper. You convince yourself n turns out to be 2. Yes? But when you want to write it down, you have to assume that n is 2 and write it in a way that makes sense. So how do you write it? The first sentence you said is correct because an odd number has some condition on it. One condition is that that number should be integer. Okay, so we say that 5 is an odd number since, I'm not saying that follow exactly my sentences, but you have to write something along these lines. So 5 is an odd integer, is odd, is an odd number since it is an integer, and, okay, what do you think I will write here? And 5 is equal to, yes?
2n plus 1.
No.
2 times 2 plus 1.
2 times 2, yes. 2 times 2 plus 1. Is it finished? You should say, and
2 is an integer.
this 2 is an integer. This is the proof. Yes? This you have to write. Then I have shown that 5 is integer, 5 is odd. Why? Because an odd number, first of all, should be an integer. So I am referring to it. 5 is an odd number since you can say, first of all, it is an integer. Whatever you want to write, but you should write along these lines. Since it is an integer, moreover, this is better, moreover, 5 is 2 times an integer plus 1. So you have to write 5 is 2 times 2 plus 1, and this 2 is an integer. So this you have to write for proving that 5 is odd. So you have to show me that you are satisfying all the conditions defined for that concept in the definition. So this is a direct proof. It is a very simple task, but you need to know how to write it down. Is that clear? Okay, so let me ask you another question. This is the problem in the book. And that was Nazanin was somehow saying this is a property of a prime of an odd number. Okay, so an example, not other example. Sometimes we say prove, sometimes we say show. Both of them means the same thing in the mathematics. So I say show that this time. Show that the product of two odd numbers is an odd number. Okay, so that's another example. Okay, I want to hear from you. How do you do the proof? So there is one part, a scratch work, you can write whatever you want to. But then after you have done everything, you have to write it formally in a polished way with necessary sentences, not just symbols. So if I ask you, I gave you a definition, so now you understand what is the odd number, and I give you a simple example, and then I'm giving a little bit harder example, but that's also very simple. Okay? The point is not the algebra involved. The point is how to learn how to write. Okay, so how should I answer this question? Yeah, if you have an idea, just tell it to me, and I will write it here. You have to say, because I have to go back and forth, then you will learn. Yes, what do you say?
The product of two odd numbers is an odd number.
Yes.
Because if you odd number odd numbers, if you define them as below, if you write an odd number, say x times another odd number, y, then you let x be equal to 2 times n, where n is an integer,
2n plus 1.
2n plus 1, where n is an integer, and y be equal to 2m plus 1, where m is an integer. The product of x and y can be written as 2n plus 1 times 2m plus 1, which is equal to 4nm plus 1, which
Plus
is,
2n plus 2m plus 1.
which can then be simplified to fit the formula 2 times an integer.
I more or less agree with you. You are convincing me, but that's not a written form. Okay, what do you write?
I don't,
Do you read? Because one way is that I record your voice and write every word you told me. Do you think it's a very nice and polished form of saying that's what I want you to learn? Yes, it's not that hard. Okay, so it's exactly like you are writing an essay. You write it once and then polish it, edit it, and write it again. So this you need to learn. Okay, this will not last forever in this course. You will sooner or later go from this, but I want you to learn, especially for Gymnasiearbeit. Sometimes when I read your Gymnasiearbeit, I see that you are actually writing whatever you want to there. You have to really make it clear, polish it, edit it, try to make the sentences more beautiful, you know. It's important. Okay. So can you tell me, I want to say proof, let me write proof here. What is the first sentence? Because you already know the answer. And by the way, the part that needs creativity, you did it. Okay? And that is the real hard part of mathematics, being creative. But you also need to learn a little bit of a skill of writing. Okay? So proof, writing means you need to assume that you don't have access to the people that are reading your proof, but you need to write them in a way that by reading that, they really understand what's going on. Okay? This is something that you need to think about it in that way. So how do you start writing? Exactly, I want to follow your idea, but let us write it in a little bit more polished way. So,
I mean, you can start with the product of 2 odd numbers is an odd number, and then continue after that.
no, it's not good. Yes? So I want to use exactly the letters that you use. Yes, can you tell me?
Let x and y.
Exactly. That is the word that I wanted to mention. So I would say let x and y be odd numbers. Yes? If you are teaching to someone as a student, you might write in your proof, we show that x times y is odd. But if you're writing for a more professional mathematician, you assume that that person also knows what you are supposed to do. So that is up to you to which group you are writing. Okay, so for example, I would say let x and y be odd numbers. I might emphasize for communicating easier with my students, so let it put it in pair of brackets. That is not necessary. We show that x dot y is odd. That is up to you. Some teachers, I don't know, have you seen some authors write very smoothly? You read and understand. Some authors prefer to write it a little bit more elaborate way so that you have a little bit harder time. You have some twist. You have to, that's up to you. So this is not necessary, but this is a very typical sentence. Let x and y be odd numbers. Okay? Therefore, you don't hesitate to write these words. There are, let me write. I want you to fill up the gap. There are such that x is equal and y is equal. Yes, something like this. Can you fill up these gaps for me? So let x and y be odd numbers. Therefore, there are such that x and y. So what do you write in these gaps? So what is the meaning of being odd? X is odd if it is 2 times an integer plus 1. Yes, is that right? So therefore, there are
Integers
integers
and
m and whatever you want to call them. You call them m and n, okay? It reminds you of a nice candy, yes? M and n. So integers m and n such that, what should I write here?
x equals 2m plus 1. Y equals 2n plus 1.
So, was it hard? And what it was logical, yes? It's so this sentence, if you want, you add or you eliminate depending on your style. But this is necessary to write something like that. It means that I am introducing the letters that I am talking. So everyone reading this sentence, they understand that I am using x and y for that hypothetical odd numbers. And because of the definition of odd number, this is guaranteed that there are numbers, integers, m and n, so that x is equal to 2m plus 1, y is equal to 2n plus 1. No mathematician will ask you why here, because they know what was the definition of an integer. Okay. Then, exactly what you said. What should I write here? I need to write some bunch of algebra here, some formulas here. So what should I write here? What do you think I will start here? X times y. So x times y is equal to, x is 2m plus 1. You don't need to explain these things because mathematics, it is clear. If x is equal to this, y is equal to this, the product of these two is also the, you really don't need to explain that much. That is clear, okay? And then you put equality. What you said, you decided to multiply them. Yes, so you multiply them, so it becomes 4mn plus 2m plus 2n plus 1. Okay? So, and then what? Is there any another? There is one more piece of algebra still needed. Yes? A factor of 2. Yes? So, between this and that, I factor a 2. By the way, this is a little bit strange because when in factorization, we usually factor something from every term out. But you understand, if you know what you are doing, you understand that you have to pull a 2 out. Why? Because you know the goal. The goal is to show that this product at the end is an odd number. But then what is an odd number? An odd number is a number which is 2 times an integer plus 1. So you have a strategy. You want to make it 2 times a number plus 1. So immediately it is motivated to pull 2 out. Okay, so I pull 2 out. It becomes 2mn plus m plus n and then plus 1. Okay? Okay. So then what? The proof is not finished. 90% it is finished. So what should I write? Again, I have to go back to my English sentences to finish the problem. So what should I write now? Yes? Not where. When you say where, it means it is already guaranteed. So this is something that you know. You need to phrase it in this way. You are right. On the other hand, so don't hesitate to write these things. Yes? On the other hand, n plus m plus n is an integer. Yes? If you want, you can explain a little bit more, but you don't need, because you can say since m and n are integers. Okay? But people usually understand that word. So on the other hand, this is an integer. So I can say hence x times y is 2 times an integer plus 1. So xy is odd. Yes? But usually students only write this part. Okay, so this is not a proof. That is the hard part of the proof, I agree. That is where you have to be creative to understand what is going on. But I would prefer to write something like this for that one. And because it is lengthy, usually students are actually a little bit lazy to write it down. But for these sections that I'm teaching, try not to be lazy. Okay, if you're lazy, I will also be lazy to give you marks. Okay, so don't be lazy, at least for these cases. Okay, any questions? Okay, there is a common mistake in the other group. We had this. A person wrote it like this. They wrote it as 2m plus 1. So 2n plus 1. So they wrote x times y is 2n plus 1 times 2n plus 1. So is that acceptable for you as well? Because it was written that a number is said to be odd if that number is 2 times an integer plus 1. Let us say that they have written every word correctly, but instead of this calculation here, they have that calculation. I can understand why they have done this, but this is not correct, you know? Why is that? Yes?
It's only proving that two with the same odd number.
Odd numbers, yeah? So be careful. If I want to use odd numbers, if you use letter n for one of them, and use letter n for the other one, it means that you are only talking about two odd numbers that are the same. Yes? But here, they are talking about any two odd numbers. So to respect that, you have to change your letters you are using. So if you decide to use letter n for x, you have to choose a different letter for y. Then it means that you are respecting that they might be different. By the way, when I choose different letters, it doesn't mean they are not the same. You know, for example, in Math 1C or 2C, if I ask you, can you solve this system? Can you give me the answer to this system? Two numbers that satisfy these equations. What are those numbers?
X equals 1, y equals
1. Yes, x is equal to 1, y is also equal to 1. So you cannot say, oh, how is that possible? You are choosing different letters, but the numbers are the same. No, if you choose different letters, it might happen that the numbers are coincidentally the same. But if you use the same letters, then you cannot say that the numbers are different. If you are using the same letter x, x can be either 1 or 2, not simultaneously 1 and 2, yes? Okay, but then what happens here? Can you, let me ask you another question. So then what happens here if I ask you to solve this one? What is the answer of this very simple problem? Solve the following equation. What do you get? Yes?
x is equal to 1 or 2.
Okay. So am I saying something against what I just told you? X is 1, x is 2. Is it surprising that x can be 1 and 2? Yes or no? Say something.
Yes, in this case, it's either 1 or 2.
Or. It's extremely important. So this is or. Okay, but between them is and. Okay? So when you say and, it means that they are happening at the same time. Okay? Then of course they can be the same or they cannot be the same. That's not the problem. This would be a problem if I write x is equal to 1 and x is equal to 2. Of course, this is nonsense. This cannot happen. Yes? But if this problem when you are solving, this is or, not and. So that's not a big problem. Okay. Any questions so far? Another thing that is in this section, it's also important to know, is the notion of implication and equivalence. Okay, so let us say that I have two statements, P and Q. For example, P can be the capital is Stockholm is the capital of Sweden. Q can be the capital of France is purpose. Yes. These are two statements. Sometimes we use this symbol between two statements. Okay, that is called implication. So what does it mean? It means that if the first one is true, it guarantees that the second one is also true. If this happens, we say that P implies Q. Okay, and the whole thing is called an implication. So is that clear? If the truth of P necessarily guarantees the truth of Q, then of course that's an implication. So for example, we cannot say that Stockholm is the capital of Sweden implies that Paris is actually the capital of France. There's no implication, yes? But for example, I can say that if x is a real number, let us say x is a real number, and I say x is equal to 3, do you think that I have written it correctly according to what I defined for you? Do you think that x equals to 3 implies x squared is equal to 9? In other words, if x is equal to 3, does this guarantee that x squared should be 9? Yes or no? Yes. So this implication is this is a real implication. Yes? X equals to 3 guarantees that x squared is equal to 9. Let me give you another example. For example, let us think it the other way around. X squared is equal to 9. I am working with real numbers. Okay? So here I would say for all x in R, if I want to be precise. Okay? Here I also write the same thing. For all x in R, do you think x squared equals to 9 implies x is equal to 3? It is clearly not. Yes? Because if I know x squared is 9, I cannot be sure 100%. I cannot guarantee that x is 3 because it might happen that x is minus 3. Yes? Because you see, x squared is 9. This is the only information that I have given to you. Can you bet on your life about the x to be 3? Then you have to be doubtful because there is 50% chance that you die. Because it might happen that x is equal to minus 3, yes? So if x squared is 9, it by itself then does not guarantee that x is equal to 3, yes? Okay. Now let me change this example a little bit. So I would say that for all x in R, x is equal to 2, and then I would write x to the power of 3 is 8. Do you think this is correct? Do you think x equals to 2 guarantees that x to the power of 3 is 8?
Yes.
Yes, because if you tell me x is 2, I can calculate x to the power 3 by writing it x times x times x, but x is 2, it becomes. Now let me write it the other way around. X to the power of 3 is 8 implies that x is 2. True or false? What? This one is true. Yes? So if x is 2, x to the power of 3 is 8, it is guaranteed. But if you tell me that x to the power of 3 is equal to 8, do you think it is guaranteed that x is 2? Yes. So here in this case, this is guaranteed because I have an odd power. There is no other possibility. So in this case, instead of writing this arrow once and this arrow another time, I use the double-sided arrow. And this means they are equivalent. And that is the other notion, equivalence, yes? So I would say that this can be combined to say that for all x in R, x is equal to 2. X is equal to 2 if and only if, you say. X to the power of 3 is equal to 8. If and only if, in mathematics is abbreviated by IFF. So if you have a math text, don't think that's a misprint. IFF means if and only if. Okay? And then what does it mean? It means mathematically there is no difference between saying x is equal to 2 and x to the power of 3 is equal to 8. But computationally it matters. Because which one is easier for our brain to process or for a computer to process? Of course, for computers, this doesn't make that much sense. But here you have how many operations involved? X times X times X, but you don't have any operations involved. So even computationally, this one is easier. But from mathematical point of view, there is no difference between saying X is equal to 2 and X cubed is equal to 8. They are completely equivalent. If one of them happens to be true, the second one is also guaranteed to be true. If that is the case, we have equivalency. Yes? For example, if I have a triangle and I tell you that two sides of the triangle are equal, can I conclude for certain that two angles are also the same? If I tell you that I have a triangle in mind and I have seen that two of these sides have the same lengths, so can you guarantee that two angles are also equal in size? Yes? Yes. Not the other way around. I tell you that I have a triangle in mind and I measure two angles of that triangle. They happen to be exactly the same. Can I conclude that two sides are the same? Of the same size? Again, yes. So this is also equivalent. So I can say that in a triangle, two sides are equal if and only if the angles opposite to the sides are also equal. So they are equivalent. There is no difference between them. Yes? And this is very important. If I have this implication, there is no guarantee this is implication. You see, this is extremely important. Some students mix things up. So if P implies Q, there is no reason that Q also implies P. Yes, for example, in this case, this one, if I call it a statement P, if I call it a statement Q, you see that the statement P really implies a statement Q. But the statement Q, which is that one, do you think that also implies a statement P? No. If I interchange, this is called the premise. And this is called the conclusion, yes? So, if P, then Q, the premise is P, the conclusion is Q. If this is true, if P really implies Q, only because P implies Q, I cannot immediately jump and conclude that, okay, Q also implies P. It might be true or might be false. If it happens that this also is true, then I have equivalency. So then I can write P is equivalent to Q. Yes? But I want you to know that if you prove P implies Q, and you want to say something about that, you have to prove it again. And might be the proofs are completely different. Okay? So for example, let me give you a little bit more tangible example. So for example, let us say that Pythagoras theorem. In Pythagoras theorem, the theorem itself is this. If you have a right angle triangle, so let me make it like this. If you have a triangle with a 90-degree angle, then if this is A, this is B, this is C, A squared is equal to B squared plus C squared. Okay? So in other words, if I want to write it as the implication language, let me call this angle A. I would say that if angle A is 90 degrees, then A squared is equal to B squared plus C squared. Okay? I have a claim here. I am claiming that as soon as this angle is 90 degrees, this guarantees this equality. This is a claim. I cannot just claim it and live with it. If I claim, it might happen that this claim is an axiom. Do you remember the word axiom? This means that we accept its truth. That's a different story. But if it is not an axiom, I have to argue why this is working. And of course, Pythagoras was able to conclude this from the axioms of Euclidean geometry. Okay? So he was able to show that if in a triangle, the angle A is 90 degrees, then A squared is equal to B squared plus C squared. But I want to ask your opinion about it. I have a triangle in my head. I haven't measured the angles. I have measured the lengths of sides. Okay? One side has length A, one side has length B, and one side has length C. And then I have taken my calculator and I have calculated A squared, B squared, C squared, and then I add them up and then I say that, oh, they are equal. Okay? Can I conclude that the triangle in mind that I have in mind is right angle triangle? Yes or no? So I'm asking the question the other way around. Can I replace these two? Do you think still it's an implication or not? Okay. First of all, my point is not that if you really know it or not, but I want you to see that they are different problems. They are not the same problems. So Pythagoras, if he was able to prove this, nice. But he cannot jump to the conclusion that the other way around has to also be true because this one was true. I want you to understand. For the second one, we have to argue all over again. Do you understand what I mean? It might happen to be true or it might happen to be false. And usually, so in this case, both of them are true. Okay? But if you see the proof of this and the proof of this, they are totally different proofs. They have nothing in common, more or less. So what I'm saying is that if P implies Q, you have an argument. Don't think that that argument, by a little bit of polishment, will also work for this case. No, might be the proof of this one is even harder than the proof of the first one, or completely different. So I want you to have this feeling, okay? If this is true, don't take this for granted. But now, if you trust me, I am telling you both of them are correct, then what can I say? Do I need to write it 2 times? I can say that being a right angle triangle is equivalent to this algebraic relation. So then I can say that angle A is 90 degrees if and only if A squared is equal to B squared plus C squared. Okay? So I don't need to write it 2 times. But do you think, can I write it like this? Yes. When it is equivalent, it doesn't matter which one you write first, which one you write second. But if it is implication, it really matters which one you write first, which one you are writing second. This is the lesson that I want to understand. Implication. What is the meaning of implication? And then if one of them is true, it is not clear immediately that the other way around is also true. By the way, I don't know, we don't use the word inverse. We replace the premise and conclusion. If I have P implies Q, this is called the converse. Converse, not inverse. So converse. Okay? So when I say that, write the converse theorem of Pythagoras, this is the converse of the theorem. Yes, is that clear? Okay. Okay, let me just ask you one question, and then we are done. I want to ask your opinion about this. I have a number in mind, it's an integer, and I square it. Okay, let me ask you this question. If I have an integer, if I have an odd number, can I say its square is also odd? Yes? Yes or no?
Yes.
Okay. So, but when you say yes, you have to have a proof for that. And then we can, of course, unfortunately, I erased that one, but hopefully you can polish it yourself. So you can say that let x be an odd number, therefore x is equal to 2n plus 1 for some integer n. Therefore, then I can start with x squared to be 2n plus 1 to the power of 2. Yes? But you have to write those sentences that I am skipping. So if you want to show, my question is that I have an odd number. Is it true that a square of that odd number is also an odd number? You want to say yes, so then you have to prove it for me, and then you have to write let x be an odd number. Therefore, what happens? X is equal to 2n plus 1 for some integer, some integer n. Okay? So hence, what happens? X squared is equal to 2n plus 1 squared. Then the algebra is simple. Okay, now I'm waiting for you. What do? Be 100% correct. Okay, so anyone else? What do you think I will do next? Yes?
Rewrite it so you have 3 factors too.
Okay, this is good. You said 2. Could I factor 4 out? Yes or no?
Yes.
I can in principle factor 4 out. And if it is a factorization problem, you usually factor as much as you can. But if you factor 4, it is not correct here. Not because the algebra is wrong. Because what we need for an odd number is not 4 times a number plus 1. Yes, I want you to respect the definitions. Of course, if it is something 4 times a number, it's also 2 times another number. But if you want to write another proof, either you have to explain the sentence that I just mentioned, but that is just a headache. Why should I do that? Because here I understand that even if I can factor a 4 out, I don't need a factor of 4. I need a factor of 2. And then I would say 2n squared plus 2n and then plus 1. And then you say that, okay, since n is an integer, this combination is integer, so x squared is equal to 2 times an integer plus 1. Okay, if you take 4 out and then discuss with me that, okay, if a number is 4 times n, that's also 2 times n. That's right, but you have to write it. Because the definition is not 4n plus 1. By the way, let me ask you about this. Could I define an odd number like that? Can I say that an integer m is said to be an odd number if x is equal to 4n plus 1 for some integer n? Yes?
You would miss all the odd numbers between 4 and 0.
Yes. So you see, again, this is exactly what I'm talking about equivalency. If m is 4n plus 1, yes, it is guaranteed that m is odd. But not every odd number can be written as 4 times an integer plus 1. Yes? Because 3 is an odd number. Can I write 3 as 4 times an integer plus 1? No. Because what is the question mark? Is 1/2. The question mark should be 1/2. 1/2 is the only number that satisfies this, but this 1/2 is not an integer. So if you define, that is what I'm saying. Another way, when you define something, in mathematics this is common. In principle, I should write this. An integer m is said to be an odd number if and only if m is equal to 2n plus 1 for some integer n. But when I start something by definition, if and only if is implicit in my definition. So definitions are always if and only if, even if they are not mentioned like that. Okay. Now another question is, I'm asking the other way around question. Okay. Now I am telling you that I have an integer in mind. I square it. It turns out to be odd. What can you say about the number before being raised to power 2? Is it an odd number or an even number? Or what can you say? What my question is that I choose a number in my head, an integer, I square it, it turns out to be odd. I am giving you that piece of information. I have an integer squared, the result is odd. Can you say that my original number is also odd?
Yes.
Yes or no?
Yes.
Okay, so you say yes, you have to defend yourself.
Because
First of all, at the level of intuition, let us try just to convince yourself there is no exams, there is no math 5, there is no teacher. Do you think this statement is true or false? If you don't want to prove it for anyone. Do you believe that there is a chance to be for this one to be true? There's a higher chance to be wrong. Which one? What? It should be true. It seems to be true. Or at least because what you do, our brain automatically, because our brain is not very good for totality. Yes? I don't know, for some reason evolution is evolved in, I don't know, evolution, we have some brain evolved in a way we can understand little pieces. Yes? So the first thing of course comes to my mind is I will give some examples in my head. Even though I know that mathematically is not probably a sound argument, but I know the difference between fiction and reality. What I do, I love it because it is very simple for my brain. That is just the fiction. But if you want to bring it on the paper, you have to write it down. Okay, so my question now: how do you defend yourself?
we can start with let x be the odd number,
Mhm.
the result that we get.
So you say that, okay?
And so the square root of x should be
No, write it down for me. So this is what I'm saying. X is an integer, yes? I don't know if this is odd or even, but I know something. I told you x squared is odd. You are claiming that x is also odd, so you have to prove it.
so square root of x, square root of x power 2 should also be odd. So it should be 2.
No, I don't understand you, okay? You have to be precise. The statement of the question is clear. X is an integer. We don't know odd or even, but we know something. We know x squared is odd. You want to prove for me that x is odd. The reason that I brought this example, I want you to know something. We will teach it later. Okay? So what I know, my assumption is that x squared is odd. So let us try to write the proof. Okay? X squared is odd. Therefore, what can I write in front of therefore? Help me. Therefore what? Yes, just say it.
X squared is equal to
X squared is equal to
2n,
2n plus 1. Is it finished?
where n is
Where n belongs to z, okay? Instead of saying integer, okay? Okay, then what? You want to say something about x. The natural algebra that comes to your mind, what is that? Because you want to say something about x. What do?
square root of x squared is equal to x.
So we take the square roots. So we say that x squared square root is equal to square root of 2n plus 1. Okay? Let us be careful. Let me say that this is a positive integer so that I don't have any problems here. Then what happens here? This becomes x if it is positive. Then what happens there? Do you see that the algebra is not working? Because can I conclude that this is odd now? Can I be happy that x is odd? Why not? Because odd should be 2 times an integer plus 1, that's it. But this is not just 2n plus 1, that's it. It's x equals to 2n plus 1 square root. So, I want you to understand, if I write this, whatever I have written is correct. But is it a proof? No. Is it a refuting? Is it a disproof? No. We are in a limbo situation. Okay? We didn't prove, we didn't refute. Is that clear? Do you have any proof for that? It turns out to be the proof is not that simple if you want to stick to what we call direct proof. but it becomes extremely simple as you were referring to somehow, but you couldn't formalize it properly. That is called an indirect proof. Okay? We will talk about that later. So instead of proving it directly, here I am proving it directly. I am trying to force myself to prove that x is odd directly, starting from my premise that I know to reach to my conclusion. This is a direct proof, going from your premise directly to your conclusion. I wanted to do that, I got stuck. I got stuck, it doesn't mean that this is wrong. It means I could not prove it. Yes? I have to change my strategy. Okay, then what happens? The idea is going to the direct indirect proof. You say that, okay, x squared is odd. I am claiming that x is also odd. You don't agree with me, it means that you agree that x is even. But if x is even, I show you that x squared is even as well, but you are telling me x squared is odd. So this is the logic. We will talk about that later. But I just want you to know, starting from the premise and continuing arguments to reach to the conclusion is what we call the direct proof. And usually so far we have always used direct proofs. Okay? Is there any questions? Okay, so I stop the lesson here. The next time actually we continue to number theory, but what we talked about this is actually important, so we will use all of them. Okay, and I also start updating the Google Classroom. Now the next time probably I will not teach, I will let you just to practice in the lesson and then ask questions. Okay, so that's it. Any questions? Have a nice weekend.